Hello, this is CS with Codify. We're back with another video. Today we're going to talk about Chapter 4 of Computer Science 961 ATS level, which involves Central Processing Unit Architecture, the von Neumann model, fetch, execute cycle, and components, and the different components of a C that make up a CPU are included in this. These are our notes that we've made, and I will first of all discuss on how you should actually look at this topic. You should memorize the topics and also need a good understanding of the topics. This topic has a lot of questions in the past papers, so please make sure that you do topical questions of this chapter so that you can fully understand it. Okay, let's start. The von Neumann model. The von Neumann model is based on when von Neumann realized that data and programs are indistinguishable and can therefore use the same memory. Von Neumann architecture uses a single processor. It follows a linear sequence of fetch, decode, execute operations for the set of instructions, i.e., the program. In order to do this, the processor uses registers. Registers, the smallest unit of storage of microprocessor, allows fast data transfer between other registers. This is a temporary storage area. So general purpose registers, as I said before, you can read from memory or some processors. It can be used by assembly language instructions. And there are special purpose registers. Some are accessible by assembly language instructions. They either hold data or memory location, but not both. For example, an MAR, well, let's go. It has PC, MDR, MAR, ACC, and IX index register, CIR, a status register. These are all of the special purpose registers which are mostly involved in the fetch, decode, and execute cycle. You would be asked to remember all of these and their functions as well. For example, the PC holds address of next instruction to be fetched. The MDR holds the data value fetched from the memory, but the MAR holds the address of the MDR's memory cell, which is to be accessed. MDR stores that data set, but MAR stores the address of that data set that is being referred. The accumulator, it is used for arithmetic and logic operations. Arithmetic operations are plus, minus, and logic operations are add, not. All of these instructions, their values that are being processed as are held by the ACC. In this register, it stores a number used to change an address value, CIR. Once the program instruction is fetched in this, it is stored in the CIR and it is weighted and allows the processor to decode and execute it. It's the last step before the decode and execute cycle. The status register holds results of comparisons to decide later for action, intermediate, and erroneous results of arithmetics performed. The CPU. First of all, it has the ALU, the control unit, and the system clock, and the IAS. The most important one of this is the control unit. It is a two-point answer. It is part of CPU that fetches instruction from memory. It decodes the instructions, synchronizes operations. These are the 3 points that you need to learn. This system clock, it is used for timing results and it synchronizes all the components along with working with this control unit. Buses. There are three types of buses: data bus, address bus, and control bus. The address bus and the data bus, the control bus and the data bus are bidirectional, and the data bus transmits data, control bus transmits control signals, and the address bus is a unidirectional bus that transfers the address of the main memory location or input output device that is to be used. Okay, there are four factors that are involved in the performance of computer system factors. First of all is clock speed, second is bus width, and third is the cache memory, and fourth is the number of cores. The number of pulses the clock sends out in a given time interval is the clock speed. It is measured in gigahertz. If the clock speed is increased, the number of execution time for the instruction decreases. The clock speed is the how many instructions are are executed per unit time. So if it's high, then the computer will be faster. But if it's too high, It can also damage the compute CPU because the limit has been crossed for the number of cycles that it can genuinely process. Bus width, it determines the number of bits that can be simultaneously transferred. It refers to a number of lines in the bus. It increasing the bus width increases the number of bits transferred. Same for cache memory. It is the cache memory is the memory that for primary memory which can be easily accessed. So faster access time if you use a cache memory, more data can be more easily accessed. The number of cores, one core performs one instruction per unit time, but more cores would lead to more instructions being processed per unit time. So it considerably improves the computer's time for the processing. Okay, this is the last fetch execute cycle. This is the most important cycle that is needed to be learned step by step. First of all, the PC holds the address of the next instruction to be fetched. The address is then copied to the MAR. That address's value is put inside the MDR, and then the MDR's data or instructions are loaded to the CIR. The PC is then incremented by one. It is either incremented before or incremented after. Then it is decoded and executed. The in decoding the opcode and operands are then identified, and in the execution the instructions are then executed by the controls unit sending control signals. Then it returns to start, and an interrupt is sent to see if more instructions are to be executed as well. So the square brackets are used to signal the MAR. It is used to signal that the address of that data is inside that component. So that's why MAR has two brackets, as you can see. And the square brackets are value that is currently in that register if it's a single one. Okay. So this was the video explaining the CPU architecture. You can tell me your questions in the comment section below. We look at all of your comments, and we your feedback would be appreciated. Our notes would be you posted on a Google Drive, and you should look at the past papers and not only memorize this but also get a good understanding of this cycle. And I hope through this interactive video you can understand that. Thank you for your time. Goodbye.